Hello ladies and gentlemen, boys and girls, my name is OctoMan and today we are taking a look into huge numbers as we know from idle games. So what is an idle game? Well, it's like where a huge amount of numbers are ticking up the whole time. You're going to purchase some things here and there and so on and so forth, and in the end you're gonna try to make as much money as you can. But there are limits to, when it comes to coding, there are limits to, let's say, a float number. A float number cannot be higher than an X amount. Same for integers. Of course, there are different integers like long integers or long integers or even further ones, but it still is not enough. Like, for example, if you have a number like a 1 and then 50 zeros as an example, yeah, it's a rather huge number. This huge number cannot be, we cannot work with that numbers in our particular manner. For example, if you want to count up some number over time, yada yada yada, then we're gonna have the issue that at one time these numbers are not going to be processable because they are just literally they are just too huge. So what we can do is we can create our own function which can handle unlimited amount of numbers. Like we can make a super long number no matter what, because we can convert different numbers into different scenarios, I would say. So the first of course, we need to understand how we can handle these before we can actually create that stuff. So what would be the usual functionality? The usual functionality would be, okay, we're going to put a 1 and a 1 and a 1. We count them up together. And the issue is, once again, an integer can only be like, I believe, 2 million or something, numbers like 2 point something, a rather huge number, but not high enough. You cannot have a quadrillion integer numbers like 1 quadrillion or even higher ones. It's just impossible. So what can we do? First off, we create a C# script and call this whatever you please and like. Of course, I would say something like, huge numbers or huge number handler or just numbers. You can put this anywhere, wherever you want and please and like, whatever. I just name it numbers, for example. And later on, when it comes to handling them numbers, like adding to this number or taking away something from that huge number, we can do this as well by we use simple mathematics for that. So first off, we open, of course, our script up and take a look into how do we understand, or how can we make a system which understands super huge numbers. There is a trick to it, of course, because there are some things we can make use of in which we can use them literally to trick a system. Hopefully it's going to open up over here. I'm gonna wait a sec or two. There we go. So this is something from the last session. So we're going to go and open this numbers script. So first things first, we need to understand, okay, what the heck is one of them huge numbers? Well, I'm going to get rid of start and update for the moment. Probably we're going to use start, but maybe not update. We're going to put this into a coroutine just to count things up. So by the way, guys, if you have any questions and so on about topics like that, feel free to ask in the chat. Otherwise, just go and go down below into the command section and leave a comment if you have any questions or anything else, as well as if you need help with your projects. Don't forget to go to my website OctoManGames.com, and there you can hire me for, let's say, an hour or two, so I can help you with your projects if you are having trouble at all times. So where can we put numbers in? We can put numbers in a float, we can put them in a double, we can put them into a string. And this is the one we are looking at today. We're gonna create a string. So a string usually is is text, just pure text without anything we want. So we can we can give it a name. We name this something like a current amount, for example. So a string is nothing else than something in quotes. For example, we're going to start with an amount of 0. So a string is always inside those quotes. So meaning what we need to do is when we count up a string, it's impossible, right? Because, well, we cannot put we cannot add a +1 to this 0 in a normal case. But what we can do is we can take this number, we can convert it into something processable, and then we fiddle it back into this current amount string. You think that's complicated? Of course it is a bit, at least, but nonetheless we're gonna take a look into this because this is really an interesting thing. So the next one is we need to trick a system, or we need to create a system. We want to hold the complete result of adding two numbers together, and this is one other interesting piece. Let's create a list. A list is a dynamic size array, literally, which starts at element 0, and it can be as long as, well, I don't know how long, huge. I'm gonna name this this list over here sum of both. We're gonna take a look into this list in a moment, or a bit later on. And we create, or we initialize that to be an integer list, something like that. So we just say create a new list of type integer, and we are good to go. So now we want to add numbers. I'm going to create a new void function over here. We can do this basically later on. We can do this public. So for example, if you hit a purchase or you have a ticker which is going to add up to this number, we are going to take a look in a moment. Then you can call this also from outside. Same one if you want to subtract, like take away something from the current existing number, you can do literally the same. But first off, let's take a look. How can we add numbers as being strings together to be a huge or bigger number? There are some odds and some things we need to take care of. So first off, we want to add two numbers together. So we're going to put in one string over here, which is going to be our number 1, and another string which is going to be our number 2. So num1, num2. You can also name them number or whatever you please and like, or A and B, and so on and so forth. So once we got them to that function, we now need to check which of them bigger numbers is bigger. So is the number 1 bigger? Like for example, this is 1,000, and let's assume this is like how many digits one of them does have, and whoever has the biggest digit amount, that's what we need to initialize our process by using some array in between before we go and put the result later on into the sum of both. So first off, let's check them. We need to have a minimum length and a maximum length because an array is fixed in its size. Once we create a new array, we need to make sure that this one array is going to be at the highest length of both of them numbers we want to add together. For example, again, if the one has 3 digits, the other has 4 digits, then we want to know the maximum length of that. So the new created array we are going to create has the maximum amount or the maximum length over here. Otherwise we can, get rid of the rest over there. So we have a minimum length, and the minimum length is, and the cool thing is strings do contain a length as well. We know how long a string has, how many characters are inside the string, so we can count them by using just num.1 num1.length. So we know how long, how many digits, or how many, let's say, symbols or digits or characters are going to be inside the first string as well as the second string. So if number 1 length is smaller than number 2 length, we know who is longer. So who is longer now? Oh, this is not what I wanted. Well, that of course depends on who is actually doing or is really longer. So if that is the case, so if the number 1 is smaller than the number 2, then we can do a simple expression. We can say, okay, the minimum length is number 1, because this is the smallest of both. So we can just copy and paste that one in. Otherwise, so I'm using an expression here because it's easier to read, I believe so. Otherwise, if length or number 2 is longer than that, then we're gonna put in minimum length to be number 2 in this case, because it's like literally vice versa. Now I'm gonna copy this complete part, and we're gonna do a second one. The second one is going to be our maximum length. So we want to know who is the highest. So literally we're going to do the same thing. We measure, is length 1 of number 1, is that higher, or in this case smaller than that? Then we just return number 2 is longer at the first place, so the maximum length should be number 2. Otherwise we're going to take length number 1, copy paste that over here after the colon. So now we got, like, this is just crossed over, so the maximum length is now number 2 if number 1 is smaller than number 2. If they are equal, well, of course, then whichever is going to be the one. Or literally it's going to take the first one, whichever comes in place, if that does match or even not match. So far so good. Now we know how much, or what is the size of number 1 and number 2 in digits, like how many digits they got. If you want to, you can always go and command things out, measure digits, like that, so we know who is the biggest number, because we need this again for the array we are going to create right now. So first off, we need to create an int array, because we want to put in numbers over here. So in square brackets, and we're going to say n1. And 1 is for our one number, and we're going to create a new, I'm going to say equal to, a new array, or integer array. But what we can now take is the maximum length we have created, or actually, let's say, how shall I say, which we have pre-calculated beforehand. We know which one is the maximum length over here, and we create an array which contains the maximum length between them two. So why do we need this array? It comes because we need to fill another array of type character with all the numbers which we find in the string, in number 1 array or number 2, or in this case number 1 digits, number 2 digits. How do we do this? I'm gonna name this character array over here to be number 1 digits. And what we want to do is we want to convert now our string from num1 to an array. So we say to char array. So we have the character array. That's what we want to do. So we don't use n1 yet, but we need to fill in n1 in just a moment, because we need to literally take these characters. So a character is ASCII character. For example, the one of the numbers is like a character of 49. You can see ASCII codes, and then you're gonna see what is a character. A character is, once again, something like a keyboard ASCII code for one specific number. I believe the number 0 should be 49 or somewhere around that, or 49 or 48. I don't know. You can look that up on your own. Just Google or whatever, and to take a look into what are ASCII codes for that. So this is storing the ASCII codes for the numbers we get from the string over here. So we converted first the number 1 into a character, so we got them into an array over here. So each single number, each single digit is now stored in this num1 digits array. So this one here is going to be the one in which we fill in all the numbers, convert them back from the string literally into an integer, so we can work with integers. So, but why would we do that? Let me make you a pretty quick example. I'm gonna make a screenshot here so I can paint on screen. So our array, like this one array, it contains, like element 0, 1, 2, 3, and so on. This can be at any length, we don't really care. But each of them numbers we're gonna put in here, our numbers are always 1-digit numbers in each of them cells of the array. So if we put in a 1 here, a 9 here, an 8 here, let's say this is our first number, like 1983 or something like, or 38, we're gonna put this number there, we're gonna put this number there, and put this number there. Once we got this, we're gonna need to, like if you have a second, like we do the same thing with our second number, with our second string. We also need to convert that, need to do a character array stuff, and then we can put them together like simple mathematics. So if we have a second array, so this one is the number 1, later on we're gonna create the number 2, just copy and paste and do some changes. Let's assume we're gonna put an 8, a 9, an 8, and a 5 in a secondary array, like over here. What is happening is when we calculate these two together, we're gonna have an 8. so we don't have something to get over. Next one is, if we purchase, or we say 8 plus 8 would be 16, would be the result. So we're going to put only a 6 in our result, but this one over here, we're going to need to put this into this next line. So we go back to force to calculate the actual result. Then we're going to have like 19, or no, it's at 18, and then we take the 1 up on top of these. So we got a 19. We're going to put the 9 back into the result later on and take this number 1 again into this calculation. Then we say, okay, 8 plus 1 plus 1, and that will be a 10. And then we need to increase the size of this array over here to fill in the 1, which is going to be this number from the taken over. So this is what we're going to need to do. But before we can calculate that, as you can see, this last number, let's say my 3 over here, needs to be in the last element of the array, not in the first element. Otherwise, we would have like crossover results like this. So the 3 would be in element 0 if we place this over there. So we want to make sure that this number here, the first number, lands into element 1. And why do we need this? Well, because otherwise we cannot go backwards in this array to calculate them two numbers together. I hope that makes sense. If not, feel free to write down a chat in the chat, and probably I gonna give it a go again for the mathematics over here. So once again, we now want to do that. We want to take all the numbers from that string, which we already took out, and code-wise we just put it into this character array. We now want to fill this number 1, this n1 integer array, with each single digit, which we're going to have later on in this string, and we want to put them literally reversed into this n1 array. How do we do this? Well, first off, we need to loop through all the digits. We create a for loop, double tap to create automatically this for loop if you want to. So where do we loop through? Well, we can say something like, okay, we're going to loop through our number 1 digits, because this is where our characters based on these numbers are already inside. So, but of course we need to say dot length, because that is an array, so we need to know how much elements are going to be inside. So this is what the for loop is going to do for us. Next thing is, we now want to put all the results, or actually all the numbers parsed back into an integer into our n1 array at position I. I is the one we are going to use here. So this is literally when we start at 0. In 0th element, we now need to put the last number of this character array. Then in the second one, in integer 1, we're going to need to take the second last, and then the, and go ongoing and so on. So literally the opposite element is going to be based on this I. How do we do this? Is rather simple. Well, once you got the idea. First off, we need to create int.parse. We will need to parse the actual character into an integer. Or we could also use, I believe so, we could also use try parse, but not really necessary, I guess. Where do we read this number from? Is actually from the number digits array. So we say num digits, open close square brackets, and which are now, we need to now fill the correct index into this to read from. So we are starting at the very end of this num digits array. So not at I0. We need to go and take the maximum length over here minus current I. How do we do this? Well, we say in here num digits dot length. So we take the full, we take the full length, num digits dot length. This is the full length of the array. We need to start at one element before, because this minus 1 needs to be inside here. And then we want to negate this number also by I. So we say minus I. So what does it mean? Again, we take the maximum length. Let's assume we have 4 digits. Then this length is going to be 4. Since element 4 is not the last one but element 3, we reduce element 4 by 1. So we have element 3 related, because element 0 is the one where we start and not element 1. And then we negate it by I. So if we are at the first digit, we're gonna start at the full length of that, minus 1, minus I. Minus I is minus 0, so we start at the last one. If it is a second number, like we have here, I would be 1 in this case. So at I1, we pass in the maximum length minus 1 is going to be the next element. So with this way, we can reverse the complete character array over here and automatically parse that into an integer array which contains the maximum possible length over here. If we got 1 left and so on, there will be just a 0 inside, or probably nothing if filled in. What we also want to do is we need to tell that we're gonna put this or take this from a string. So we say dot to string over here, because we want to parse. We're gonna use parsing for a string, so we need to convert this digit number first to a string, then parse the string into an integer array. I know that sounds totally confusing, but I believe, I can tell you this is going to work. So now we got the numbers over here together, and we now have everything, every digit from this number 1 string, we got this into n1 array. Now we do the same thing, of course, for the second array. So we first off take n2. I'm gonna copy this complete piece over here because we just need to change some small amount of numbers. So this is like number 2. We take n2 over here. So we create a new integer array, and we now name this one here n and number 2 digits. We're gonna take it from number 2 character array. Then we go and loop through the number 2 digits length, and we take here n2 as being our parameter to take our numbers from num2 digits with the num2 digits length minus 1 minus I, a dot to string. Once again, this dot to string, we need to convert this character array to be a string back, or this 1 digit back to a string, and parse that into an integer array. That's why we're going to do this. So we literally do this 2 or 3 times over here. Nothing fancy overall. Now we go into mathematics. So the first thing is we want to clear our sum of both list. So clear list, something like that. So which list? Well, the one we just created beforehand, because we now want to take the n1 and n2 arrays and want to put them together. We want to add these numbers together. We need to start at the very end now, and the fun part is we need to convert it back into something else later on to make it, let's say, readable. But in that case, we can spit out huge, really huge numbers. There are no common numbers. These are just full integer numbers. Keep that in mind. So we clear the list first. So we say sum of both is going to be, well, dot clear, I guess. Dot clear, open close parentheses, close the line with a semicolon. Now we want to do some logic. So some mathematic logic over here. First, we need to have an integer, which is going to be our carry over. This is the 1 or a 0. We're gonna have to carry over every iteration if needed. The carryover, once again, is going to be the number which, for example, let me make a new one pretty quick. If we're gonna have like one number here, this is a 9, this is an 8. If we count them both together, we got a 17. Our result integer would contain a 7, but this one is left. So we need to carry this one over into the next one. So if that is a 5, and this one acts as an example is a 3, then we need to carry over this number 1. If it is a 0, of course there's no carryover. If it is a 1, we carry this over, so we add 5 plus 3 would be 8, plus the carryover would be 9, and then we don't need to carry over anything here, or we just stop the the calculation over there. Pretty easy. Hopefully you got this. I guess you do. If not, once again, use the chat and figure out how to use it, and give me any message if you need to. So what we want to do now is we want to loop through the amount of the maximum length possible over like all of them 2 arrays and calculate them together. How do we do this? We first off create another for loop, Pretty simple, and in here we're gonna use the maximum length as being our indicator. Once again, maximum length is the one which has the longest amount, the highest number. So if that number has 5 digits and that has 20 digits or 100 digits, then this 100 digits will be automatically maximum length, depending on, you know, who is longer in this case. Now let's do some mathematics. Well, the mathematics is just, we first off want to sum up our both numbers, like the ones we currently iterate through. So we're gonna create a new integer sum over here, and now we want to do our mathematics. We're gonna say sum is equal to, I'm gonna put this into parentheses because we need to make one extra below or behind it. So first off, we take our n1 number, iteration I, we start at element 0 first, which is once again the last number, because we need to calculate backwards, and we now do our calculation. We want to calculate n2 to it, which contains also any number. In here we're going to take I as well as a parameter. Now we're going to add carry over to it. So if carry over is 0, well, nothing is going to happen, especially in the first iteration. There will be no carry over. So, but we need to take this into consideration. And now what we want to do is we want to modulo 10 the calculation. What does modulo 10 do? Modulo 10 means whenever this number reaches a number 10 or higher, it will go back to 0 and continue counting up. For example, if we're going to use our calculator and the result of this complete numbers over here would be, let's say, 19, which would be the highest number, by the way, as a result, and we're going to say modulo 10, then this is going to say, okay, I need to take this result number minus 10, and then I see, aha, this is the rest. If that would be a higher number, of course, then we would do modulo 10 as much as it can until there is one rest left. Because our digits should never be higher than 9 in any of them. So any number between 0 and 9 is cool. Good. And then we got the carryover, which comes from this 10, of course, which will be filled in a moment, of course. So now we need to do some measurements. Well, first off, of course, we want to add the result to our sum of both. So we're going to say sum of both dot add. We want to add our result for this one particular number. How do we do this? Well, we just add sum to it. So we're going to now fill it the opposite way. Like whatever the result is going to be in element 0, at least at this particular point. So we're going to just, you know, keep up going until we want or stop or so on. Now, in the next iteration or the same iteration, we want to see if we have a carryover actually. So we literally want to know the same thing here. We want to see if when we put all of them numbers here together, I just copy and paste that. If we say n1i plus n12i plus carryover is bigger or equal 10, then we know we got a carryover. I need to put another pair of parentheses around this. No problem. We're going to do this. Or actually we can take, we do a second one here just in case, so we don't get any issues later. So if n1 plus n2 plus carryover is bigger or equal 10, we're gonna set carryover to be equal to 1. Otherwise, we set carryover, it doesn't like me today. Otherwise, we're gonna set carryover to be equal to 0. If you don't like this if statement as it is, you can also do an expression here as well. How would you do this expression? Well, carryover is equal to n1 plus n2 bigger. This is going to be the expression actually, so we put this in here. If that is the case, then we say question mark, and then we can put in 1. Otherwise, we can put in 0. Something like that. And if there is any weird issue, it comes from this pair of parentheses, so or this one parenthesis. So we can also put this in an expression. So we don't need an if statement over here, but it's easier to read if you are a beginner. So carryover is getting set to be 1 if that is the case. otherwise it's becoming 0, so 1 or 0. So once you got this, we're gonna check another thing. That means if we wanna, if we do have a carryover, so if carryover is bigger than 0 or equal to 1, it doesn't matter which one you choose, both should work, then we wanna add sum of both dot add to the carryover. So we put this into the next iteration, or at least gonna put this like at the very end to it. Cool. Now we got, this is our mathematics. This is where we now put all these numbers together. We iterate through the complete maximum lengths. So we know just a number. We're gonna put everything into sum of both. We're gonna add them together and sum them up. Like the result of that will be summed up. Modulo 10, just to see if the carryover is over there. We're gonna add the sum of whichever, and we're gonna update carryover, take it with us into the next iteration. Here we just set it to be 0 to start somewhere, and in here we just carry over if there is something to carry over. Like if we have like 2 9s at the very end or at the very beginning of the number, then of course we need to carry over this last number 1 here as well. Cool, now we need to visualize that stuff. So there are hundreds of possibilities for you now. We want to visualize that stuff. We're gonna do some testing here as well later on, because we need to put something together to visualize the results. So we can print a result, we can put this in a debug log, we can put this anywhere, and so on. Hi Philippe, thanks a lot for tuning in. Hope you enjoy this one. If you have any questions, feel free to ask. Sorry, I didn't saw the chat earlier. So how do we visualize that? Well, we want to store the sum of both back into our result, don't we? So to do that, we first off want to say our current amount, we want to empty this one out. We just say is equal to, just quotes, nothing in between, no space, no nothing, you know, that's what it is. Then we want to have some kind of maybe a view string. You can name this whatever you want. And then we need to, then we can, let's say, put anything we want. We can put an enum, like if that and that, if the length of our sum of both is higher than x, then we're gonna only show some specific amounts, or and so on and so forth. I just show you the full number now and how we can visualize that with dots and commas or anything like that you want into our number, so we can visualize how many zeros we're gonna have at the end in our view string. So the view string is not the same string as our result string. It is going to be just our visualize string. So we create a new string. I name this view string. You can name this whatever you please and like. And now we're gonna say is equal to nothing first, because, well, there's nothing inside. Then I want to have an integer, which is going to be, I'm gonna name this at point, is going to be equal to 3. So every 3 numbers I want to add a point. And I need to count this number up and down, up and down, up and down, until this number is reached to add a point into my view string. So again, we can visualize that at our, however we please and like. I create another for loop over here. Now we're gonna do reverse recursive adding. So we now go through our sum of both list, but back to force. So back from the last element to the first element. So instead of counting I, we start not at 0 over here. We're gonna use sum of both dot count -1. Not clear, but count -1. So we take the last element first. Then we're gonna loop through I. Meanwhile, that is bigger or equal to 0. Meanwhile we do so, we're gonna say I minus minus. Again, this is called recursive, recursive looping. So we go backwards in a for loop, not forwards, as we did over here. We say here plus plus, and we wait until we hit the length, or actually 1 minus the length. And here we're gonna start at the back and wait until it hits higher or equal. The equal sign here is important, otherwise we miss one number. Is higher or equal 0. Meanwhile we do so, we're gonna go in the elements list minus minus, so we say -1 literally. So what we want to do is to, from our current amount, we want to put our numbers into the current amount as being a string. So we're going to say sum of both in square brackets I. So we see in that string later on that our result is going to be represented into this amount. Why do we plus equal over here? Well, the sum of both is going to use a I, or the sum of both indicator, which is going to be just a number, and it puts it into the string. So we shouldn't need to convert this or do something like dot to string or something like that. Shouldn't be necessary. If that is the case or changes over time, then add a dot to string over here, but I guess we don't need this. We're going to do the same in our view string. So we literally do the same. We want to add our backwards running numbers and want to add them into our string over here to visualize again. Now we want to add our point in between. Again, you can use any visualization method you want. You can even use this, if the number is higher than 1000, then you do a 1 and then a short 1000 for 1000, like 1th or whatever you like. I'm gonna show how to view the complete number in its full length. So we say I modulo at point. If that is equal to 0, if that is equal to 0, so again, we gonna modulo I when I is actually 3 or higher, or is 3, then we set I back to 0, or actually we see if that result is going to be a 0. So if I modulo at point, like I modulo 3 is returning 0, then we want to add a point. But also we want to make sure, that I is not equal to 0, so we don't have this into the first iteration, which would otherwise happen over there. If that is the case, we want to add to our view string only, not to our current one, to our view string only, we want to put in a point as a string like this. So now we got numbers and we got a point in between them things. And then of course we are good to go and we can print the result. So over here we can print or debug or whatever result. How do you do this? Well, in the console it's rather easy. We just say print the actual view string. Print view string like this. Okay, now we were adding all these numbers, like number 1 string and number 2 string. We were adding them together, seeing which is longer. We're gonna store them in a character array. Then we parse them from this character array into a reversed array list, or array in this case, for number 1 and number 2. We were parsing them. Then we clear our sum of both digits list. There will be always the numbers inside, so they keep updating, but we need to clear the list to put in the new list every iteration. We're gonna take a look for carryover. We loop through all the numbers, sum them together, and add the result of each iteration in how high these numbers are going to be into the sum of both list. We're gonna see if carryover is bigger or equal than 10, so we can add a carryover to it. Otherwise we stay at 0, and then we're gonna do the visualization with some kind of a view string. By the way, later on, if you like to, you can use that string and put this into any text component in a TextMesh Pro component, or whichever. Just instead of printing it, you just send it to any UI, any text you like. And please, no matter how you're gonna show that, if you want to, say something like a 1K or 2K, 3K, 4K, you can do this as well. You just need to check the length of sum of both. So something like if sum of both has 10 digits or 20 digits, or 20 is the count is 10, or the count is 20, 30, 50, 100, then you just put in the correct letters. You can use an enum for that if you want to, or just a switch or whatever you please and like, and put this below or behind the number. And you can also shorten the view by this and that amount, depending on how you want to structure that. Okay, let's now count up some numbers. or let's tick up some numbers. We're gonna start small and then we'll rise big, of course. So at first I want to use a IE numerator, which is going to do our ticking up automatically. So I do not recommend to use the update loop for something like this. Make sure you use an IE numerator because we can also time how long or how often we want to tick this one up pretty easy. So while true is going to be like something like, okay, it will never end, it will run constantly. While true, we want to wait 1 second. So we say yield return new, wait for seconds. 1 second, every once a second I want to get something. What do I want to get is I want to add a number, whichever number we can pass in later on also from any other ticking system. We can say, okay, we want to put, the first one is I want to add one number, one amount to our current amount. So these are the two arguments we want to need, or we just need at all. The last thing we need to do is we go into the start and say start coroutine, and we call tick up over here. Tick up, open close parentheses, close the line with a semicolon, and don't forget to save the script. Now let me close all of that stuff over here. We say no, I don't need this. And I create myself a game object, or you can put this wherever you want to. You can put it into your game manager object if you got one, and if that is anyhow necessary. I just let it be as it is and take number script and put this in here because it has to be in the scene, otherwise we cannot call start and so on and so forth. Now let's press play and check the console. Let's see what's going to happen in the console. Because we are printing every once a second, we're gonna print some results. So as you can see, we are using now two string elements. We convert them back and forth, and you're gonna see whatever these results are. But what you don't see is, well, what is really happening right now? We just see the result. The result seems to be correct. But how does it look? If you want to, you can pause the game. And you can go here and say debug mode. And in here we're gonna see the sum of both array, or in this case it's the sum of both list. Sadly, I cannot see this. I cannot open this. The current amount, as you can see, is a string parameter. It is currently 17. This is what we also got here as the result. So this seems to work. Pretty nice. I want to show you how sum of both is going to look. To do that, I just make this one public. Or I could also use a, I guess, serialized field if I want to. I don't know if that is even possible by list. Let's try. Serialized field, don't forget to save and see if we can visualize or actually click on sum of both. Yep, we can. So the list starts empty. And now let's start from scratch once again, and let's see what the sum of both is going to do with this list. So as you can see, element 0 is now filled with these numbers. So we started at 0 literally, then we got up at 1, now we are 9, and now as you can see, we have a carryover. So once we are hitting number 11, we have the carryover, which is going to produce a 10, was a carryover already. The 11 is a carryover as well. Don't forget this. It always keeps on pre or recalculating the same thing the whole time literally up until whichever point. Let's speed things up. By the way, don't forget, if you have any questions, feel free to put them into the chat or down below in the comment section, and also check the my website if you need some help with your projects to struggle with. And what I want to do now is I'm going to put a 0.1 here, so it's going to be a bit faster. So it's like running upwards over here. So we're going to see the sum of both in action, like what it is really doing. Probably it's going to take a bit of my CPU over there, but we'll see what's going to happen. So every once a second, like every tenth a second, you're going to see there are some numbers over here. And every time, oh, there seems to be a bug. Every time this number counts up, we should see these numbers rising here. But again, there seems to be some bug over here. So what is the bug? If you can see here, it never goes up to 10. It should be not like 2, 2, 2, 2, 2, 2. It should be like 100, 200, 300, 400 until 900. So it seems that I have a typo somewhere, probably. So let's take a look pretty quick. What could be the issue over here? I'm gonna take a look into my notes pretty quick, and probably I'm gonna find this rather simple. Actually, the question is, what is the real current amount over there? And probably there's some mathematic issue I forgot to implement, or something like that could happen. No issue with that. So it does not populate this number. It doesn't go like in here. And current number is also wrong. Okay, so let's see where the bug is, and yeah, let's try to figure this one out. Maybe I just have a something forgot over here, where a number 1 is a number 2 or something like that. We'll check that out pretty quick, or I'm gonna do that, and let's see where the issue comes from. So let's start at the very beginning. So we measure these. Num1, num2, probably the carryover doesn't really work the way I want it to be. Maybe carryover doesn't work correctly. So maybe I'm gonna put this in a to and if statement again, just to see if that probably gives us some issue over here. Maybe I need to put this, I don't think that I have to, but let's try that pretty quick. I don't think that is going to give us any different result with these parentheses around it, but let's see, just in case. Maybe it is just that thing. If not, I'm gonna try the other piece over there. Nope, that is literally doing something wrong over here. So probably this carryover thing here has to be somewhere else. Oh yes, this carryover here has not to be inside the for loop. It has to be outside the for loop. It's like if there is a rest of a carryover after we are looping through the complete content, don't forget to save, the carryover comes at the very end. That is the issue. So that was the one I just didn't realize, it seems. So let's try again. Let's go up and see if we go and get some the correct numbers actually. So we got a 2, now a 3, 4, 5, 6, and so on, going on. We can also see the huge numbers over here rising up in the chat. So now we got a next carryover, which is correct. So once this number here hits a 10, literally, it's going to carry over a 1, and we have a 200 and something number. So what you can see right now is going to run constantly, rather quick, as you can tell, with a bunch of numbers over here. But now we want to see, what is a real high number? This is why we are here, right? So this is why you guys are here. So what we can do is, instead of, I'm gonna slow that one down over here to be 1 second each. Let's add some different numbers. Like, let's say we want to add a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever number every once in a while together. So we are starting at 0. And then we add them together. I need a calculator for that in a second, but just to see if the result is going to be correct. So the first one, the number 1 digit is going to be the long one. The current number is going to start at 0. So the first number should be the one we are going to add after 1 second. We can compare that. So I'm gonna make a stop. You can see this is the one we just added over here. Now when we add the second one, like the same number a second time, we want to control that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we want to put a 10 and a 20, and we're gonna say times 2. This should be the next number in the next iteration we should see over here after 1 other second. So I'm gonna pause again, gonna take my calculator out here, and now we can compare. You're gonna see now we have a rather huge number, which is pretty heavy already, but you can see the result is correct. Awesome. Now, whenever we now go and let this one run, also you see these dots are now coming into play. You can see now that these numbers are now pretty good running upwards, the length of sum of both is going to increase, and depending on how fast we are going to upgrade all of that, all of these numbers are now going up and up and up and will never stop, literally. So what you can see here as a result is going to be an already formatted, like every 3 digits to be readable easier. Every 3 digits we're gonna see, okay, this and this is that amount, and then we can view and visualize that in a text field, because that is a string. You can put this anywhere you want. You can let this pop up if you need to, or sometimes in games you're gonna have number like text fields anywhere. So how would you just say, okay, if there is this and that amount of digits, how would you do like a 1k, 2k, 3k, and so on and so forth? How would that happen? Well, two possibilities you're gonna have. You can count the complete sum of both, like depending on how long that is, you're gonna add a k or a th or whatsoever, or you can use the results dots, which are 1, 2, 3, 4. How does that work? Is every time we would create a dot, we can count a number up, and depending on them you can say, okay, whatever this number is we're gonna count up, we multiply that number by 3. That's the digits we don't want to see probably in the end, so we need to have a second iteration, and we only want to see this number here at the very front, behind the last dot. So what we can do is we can put it like that into some kind of a switch. For example, if this result is going to be 1, then it is we're gonna see this number here but a k behind it, and the k comes from how many points we would have here. The next one would be an m for million, then billion, and so on. You know these numbers better than I do. So this is how you're gonna create and work with rather like extreme huge numbers at the very end, which are printable, which are calculatable without any limits, but the size of the sum of both lists. So I don't know how long the list can be. Let's do some super fancy quick stuff over here again. Just let's try to ruin something on my side here. Probably my computer is going to crash. Let's see, I have no idea, but it shouldn't. I don't want to save that thing. I just want to hit play and see how high these numbers can go in let's say a minute or two. So as you can see, these numbers are running high pretty quick over there, so they're always doing the same thing. It takes now quite some time to get into higher numbers, so we have now 14, or in this case 15 digits. So just assume or think about that you're gonna have digits like that in your game without any issues. You can see it is rather quick. I don't know how long the calculation is. You can check this on your own, like a calculation time of each of them adding together. And yeah, that's literally everything you need to know. There's one more thing you probably want to ask yourself. How do I get, or how do I take away something from this number? Well, it's the same thing. There's just one thing to keep in mind. You don't add them together. You need to negate them from each other. So for example, if you are gonna do a beautiful painting session again, like if you wanna get one from the other, let's say you have a 1999 and you wanna put away, like you want to say minus 120, you want to say this number between this number, right? So 9 minus 0 is 9, 9 minus 2 is 7, 9 minus 1 is 8, 1 minus 0 is 1. So this is basically the same thing as you learned in school in first class, or probably third class, I don't know really, or maybe second class. This is how you learned that. So you take the bigger number, this is important, so probably in our case it's going to be n2 minus n1, and is there going to be some overhang? Well, there's no carryover, because, well, what's not here is not here. The highest numbers are going to be 9, so the 9 minus 9 is 0, so it's the smallest number, so you don't even need to have a carryover at this point. So and except you're gonna have minus numbers, like if you say this one is not the biggest number, but this one is the biggest number, but well, that's not part of that, then you would of course have a carryover. So you need to always see which is the highest number and which is the one where you want to take it from. So in here, N2 is going to be, or should be, the current amount is going to be N2, and this is the one you want to subtract. Like when you are having a shop system, you want to buy a something, it has this and that amount. Again, you just need to put in the string numbers, or a string, and put all the numbers like whatever the costs are. If you need to convert cost into whatsoever, then you need to do literally the same thing, just convert it from one thing to another. Like for example, if you have a multiplier on numbers or something like that, then you round them up or down and so on and so forth, and then you just show them in your screen. Once again, everything the same thing. Again, for a subtraction method, you do all the same stuff again. Instead of add, you name it subtract. Let's pretty quickly create that. I'm gonna copy this result or this complete function and name this subtract numbers. So in here we're gonna take number 1 would be the current number that's important over here, and so probably you're gonna make yourself a command here like current is N1, and the number 2 subtract from number 1 is going to be this one. Then you want to do the same thing. Who is longer? You're going to take the maximum length out of both. You're going to divide, or actually you parse them back into a string. You put them into the N1 and N2. You reverse them in their logic. You're going to clear the sum of logic over here. You don't need a carryover, so literally we can take the carryover away. And then we say N1 minus N2. And in here as well, basically we don't need the carryover, as I said before, and we don't need this carryover, so you're just taking one number away from each other. So the highest number is going to be probably, if the bigger number, I'm not quite sure yet. Let's see, if I have a 0 here and a 9 here, 9 minus 0, well, is that even what is going to happen? That's probably the carryover then, because you cannot take away a 0 from that 9. Like if you have 110 and a 99, well, the result is this minus that is going to be this. It's going to be, nothing actually. How do you do that? That would be the carryover. Oh, that's interesting. So then what is going to be left literally? Like if you the 0 would be a 10, kind of. Which we're gonna get here. So if we take from 0, we take 9 away, or do you do this the other way? No, you say like this. You need to calculate that like that. That my fault. It's not like this one. It's the opposite. Like if you have a 110 and a 99, you're gonna say from 9 to 0 should be 1. So this is going to be the number we are actually looking for, because that is literally representing a 10. That is something interesting here. So from 9 to 0, if that is a 0, it is going to be reduced by 1. If that is a 9, of course, and this is a 9, so both are the highest numbers here. So the only issue is going to be the 0 over here. So we need to make sure that we calculate this, of course. There will be no carryover in this case, but we just need to treat this number here a bit, let's say, different. How do we do this? Let's see. We do not want to do this. Let's see. We're gonna do a sum from N1i minus 2, but before we do that, we want to know what N1i is. In that case, if N1i is a 0, then N1i should be a 10. But then the sum is going to be a different one. If the other one is a 0 as well, then we need to make sure that this one is going to stay a 0 over there. Or literally, if we have like a 0 minus a 0, then of course the result should be 0. So we cannot really treat it like a 10, I would say. So probably we need to do two things over here. Let's see. We will figure that out pretty quick. Okay, so if n1i is a 0, so the one which is at the top, the number 1 which is at the top, we want to see if that is a 0. Then we want to probably also see if the other one is actually bigger than 0. Like n2 is 1, or if that is the same, we don't literally do anything, so n1 is treated as a 0. Probably we're going to use some kind of a temporary number, and we need to treat it like a 10, and then we get the result out of the temporary file. Probably that's not a bad idea. So I'm going to put an int temp over, or let's say over, temp over, or temp something is equal to 0. So how to do that? Well, if n1i is equal to 0, then temp should be a 10. Then we need to do the calculation and here with the temp, like this. If that is a 0, if the result of both would be like, let's do a second check here. If n2i is not equal a 0, I need an exclamation mark. So if n1i is 0 and n12 is not a 0, then temp has to be 10. Otherwise, else temp is equal to 0. I guess. Is it right? Well, yeah, because we are representing only n1 in this case. Yup. So what we now need to do is we're going to take temp, or whatever temp, actually in this case here, if that is not the case, then then temp is going to be n1 in square brackets, I. So if that is not the case, then it is what it is. Because yeah, I guess that should be right. So if that is a 0, it should be a 10, but it is only a 10 if it is only a 10 if this number is not a 0. If that number is a 1, then it needs to be a 10. If this would be a 0, so both are 0, well, then it can stay literally whatever it is. And then we take temp. Then we take temp and sum it away, or actually we take n2 away from this temp now. Yep. So that should carry over everything completely correct over here. So let's try that. I'm gonna use a small number here. I want to take away 1 at a time to see if it works correctly. And in my current, I start at a rather high number, let's say 1,000 or 2,000, whatever. Yep, 2,000 sounds good. 100 would be even easier to read, but nevertheless doesn't matter at all. However, my tick up would be a tick down. Instead of using add number, we would use subtract the number. So, and again, we now need to convert or make this one the opposite. We need to say the first number is going to be the current, and the second one is going to be the one which we want to take away from it. So if you later on have a system, so you know what to take from it away, then you just pass it into this function as a second number. So again, current is number 1. Don't forget that. So this is different to the add one, which is just the opposite. Let's see if that works as it should. So the next number after 2000, which should be the current in a moment, once loaded, well, hopefully it does update itself. Sometimes I have seen issues with that. So we start at 2000, and now it's taken away. Oh, we need a carryover then. It's taken away the last one, which is okay, but it doesn't care about the other ones. Because, yeah, why is that? Well, each iteration we need to get rid of that number as well. So we need to carry over. And the carryover would be a 1 actually. So if we take away a 1 anywhere, all the other ones need to have a carryover in this case. Ooh, that's insane. I didn't thought that it's going to be that complicated. So let's take a look into this. I believe, yeah, we're gonna make use of the carryover again. So int carryover. We just need to know if there is a carryover necessary at this point. Why? Because, well, modulo should do the same thing. It should have an issue with the number 0 at any time. So any time any result would be a 0, then we would have a carryover, which we need to take away from the other side as well. And then we probably need to take care of that if we dip or would dip under 0. So we anyhow need to modulo 0 I don't know. If we do dip under it, then we don't have a negative number, but we pop up to the next number. Let's see. Carryover, we start at 0, just in case, in our mathematics logic for the subtraction number. And now let's see. We start with the temporary number here at 0. So this one, the first iteration did work. But if that is the case, we want to say that the carryover, that at the same time, the carryover has to be equal to 1. And then we need to take away that also, probably also here in our calculation. Oh, we don't really sum that things together, do we? Oh, we do here, like temp minus n2, and here it should be minus carryover. Probably, actually. Let's try that first. There might be something, because, well, if there is at the very end a 1 left or something left, or as long as it's higher than 0, we can do this carryover. Otherwise, we should break out of it. So if the last number is literally, yep, that's what I thought. So we cannot use, I'm gonna show you again. We cannot use that value as we wanted to. So what is happening from our 2000, which we started with, these zeros here got negated by 1, so we get a negative number in here as well. So we want to make sure that this 0 becomes again a 10 by each of them iterations. We need to make sure that them are going to be this. So how should we do this? Let me make another painting here. I just want to be sure. And if you guys have any tips and something like that, feel free to slam them into the chat. So again, we got a 9 whatever number. No, let me restart. Let's start with a 2000. What should happen if we're gonna take away 1 every iteration? We're gonna say this 0 becomes a 10. We got this number is going to be the carryover, so we know that we have to carry over a number to here. So the next thing is, if that 10 is going to be here, we're going to say 10 minus 1 is equal to 9. Pretty good so far. But we still have this carryover. So we need to say we keep the carryover for the next one. I need to see again, okay, if there's a 0, we need to take away the number 1 from the 0. So this one should be seen as a 10 as well. And probably it does not matter if this, whatever this number is going to be over here. So per each iteration, we need to iterate through all of them and take a carryover if one of them is going to be, well, a 10. actually a 0 in this case. And also we need to carry over this one up until this number here as well. Whoa, that's pretty tough actually, I guess. So how do we do this? So we create the temp, which is our 10, or gives us the 10 over here. Well, probably this is a bit overwhelming, because a 0 minus a 0 is, it shouldn't matter, because it should always be treated as a 10, shouldn't it? So if 1I is equal to 0, then temp is going to be 10. We're gonna have a carryover is going to be equal to 1, and otherwise we're gonna have no carryover. So carryover should be equal to 0, I guess. So we don't need to put in a carryover over there. In the next iteration, we should see, which is the next number, should be also 0, should be seen as that, and then should be taken away the carryover. Hi, Unlegit, thanks a lot for tuning in. Let's try again. So hopefully that works right now. Gonna start with these numbers. Let me go downwards a bit and see what's going to happen here. That's interesting. So it keeps on going up until the last 0 is gone. And then it starts again from, well, it doesn't even take the 9 into consideration. So it doesn't take it away completely correct, because, well, we need to carry over the 1 over here anytime we hit a 0. Have a good one, Unlegit. Thanks a lot again for tuning in. So this carryover needs to be a bit different then. So meaning we need to take care of the carryover even afterwards. So I believe that is again going to be the piece where, or which I just had the issue with before, like with this add number piece over there. We're gonna pause them. We're gonna set carryover. And after that, we're going to carry over. If carryover is bigger than 0, then we need to, negate, whatever we need to do. We need to negate from N2 over there, I guess. So there shouldn't be any, that are the wrong ones here. That should be there. So it shouldn't be actually tracking or going into add number over there. So again, if you guys have any ideas of that, feel free to pop them into the chat or leave a comment down below. Maybe I just maybe I don't see where the issue could come from, which obviously happens currently. Okay, so again, I'm gonna make a temporary number of 0. I'm gonna use whatever currently is in here. If that number is a 0, I'm gonna say, probably that carryover could not be a number in here. If it is a 10, we got a carryover, but also we have a carryover onto all of the other numbers. But how do we, or when do we reset a carryover? Do we do this like every iteration? Like carryover is equal to 0? Well, shouldn't be, because if it is a long number, any kind of a long number, like this one, we need to carry them over. We need to make sure that we take away from this huge number, like a 1 here, a 1 here, a 1 here, as well as a 1 here, but only if that is a 10. Then we need to take away 1 of here. So if that returns a 9 literally, then we also need to carry this one over to this iteration. So the carry over per iteration needs to stay 1 constantly if there is a 0 in n1. I have no idea if that works now. I just did minor changes, nothing fancy. But I want to see if I can get a good result over here today. Well, didn't took over everything. Okay, so this is an actual issue there. So how do we do this? That's why it's starting literally with the carryover in this iteration, because if the last one is the last number is going to be a 0 and carryover is here, it actually makes it so that this carryover comes every time on top, literally. So this carryover over here cannot be set literally in this thing. So we need to have a separated carryover check, I guess, per each iteration. Like if the result 10 minus this is so, then it doesn't calculate it within this one, but it should do this in the next iteration, literally. So the next number would also be a 9 actually, and automatically. But if the last number is not a 9 or not any other number, then it probably does the carryover better. So, and if we reset carryover here at the very start, it probably doesn't work the way we want. So we have a temp. We have an n1. Let's get rid of this one. So we don't use carryover yet, so this is why this warning is popping up. If that is seen as a 10, otherwise it's seen as this. Let's start with that without the carryover, just for the sake of testing. Okay, something is pretty weird over there. So it's not really working here. But what did happen at the first place? So it added these numbers here to it instead of taking it away. So we would have to, and this is the thing. If that is a 0 and that is a 10, why is that not going to give us a 9 instead? Like if that is going to be a 0 here. Good question. I'm gonna make a bool here just in case. Gonna set this one to be equal to false. If that is the case, I'm gonna put is 10 to be equal to true. Otherwise, I would say is 10 is equal to false. And I guess carry over is equal to, well, if is 10 is true, carry over should be 1. Oh, it's question mark, colon, question mark first, 1, colon, 0. Without this. And what then? For the next iteration, I'm gonna put in a negative carryover if the last number which has been a 10 first, like if that returned a true in this iteration, then we should have a carryover, otherwise we shouldn't have a carryover. Let's try that. Because the 10 in this case means we were having a 0 at this point. And we should take the carryover completely over the complete iteration, literally, and also for the last number. But as we can see, the number 2 at the very first place, which is actually not going downwards. And this is another thing. The carryover should carry over the number from here, from the last number, into the next number as well. So what does it mean is, like, if the last number gets a carryover to be true, it should sum away from the second, or inside the second iteration. It should take the carryover to the next iteration. It doesn't do it because we reset the result over here. We need to do this over there, I guess. Let's save that and test again. Number 2 again is not correct. Nope, it doesn't do it correct. What do I miss? Let's try to debug that. God, I didn't thought this is going to take so long to figure out. What do we wanna know? First off, we want to know carryover, and plus, well, what do we want to know? We want to know let's say we want to know temp. What is temp size after calculating this? And if that doesn't work, we're gonna take a look into the boolean and see if that does what it should do. Probably there's something I'm missing here. So we're gonna have a 1 carry because it was reading a 10 at this point. In here we got a 0 because the carry is going to be because a dtemp is going to be a 2. So that's why it does carry. So we need to take over into the next iteration. We need to take over what just came from this particular one iteration. So we need to do this carryover afterwards, after this calculation, I guess. Is that right? I believe this is the issue. We do not take it into the last consideration, so we need to somehow know if the last number was, or the last result was, a 9. And then we probably need to take a carry over. How do we do this? 10 is true. We go again into the next iteration, and what we see is N1 and I'll probably... We need to look back 1 number. We need to know what the last number result was, like here at after this calculation, it seems. So that's why the number 2 is not going to get reduced. So in the next iteration, let's see what the carryover would be here. Debug.log. Oh, debug.log carry is plus, and then we say carry over, and this iteration is it 0, 1. So the first one should be 0 because it doesn't carry over anything. It pre-calculates itself to be a carryover, but I want to see if it probably gets wrongly updated or wrongly seen, which I assume is going to happen over there. So as you can see, first iteration it says 0, 1, 1, 1, and then it does, so it does a false over there. So if carry, we probably need to take care of carry beforehand, like before we're gonna see if that is completely correct over there. So we first have to do the calculation of them numbers, but and set the carryover, like the updated carryover after the calculation. I guess this is the issue over there. So like where would we put this? Literally, we're gonna do two things. We can say, okay, we're gonna sum temp minus that minus carryover in, if that is true. Otherwise, we don't need to put in the carryover over here because there will be no carryover anyways at this point. So if that is the turn, but the downside is the current number, like the last number, is not going to be representing a carryover number, which is absolutely fine. Let me undo that pretty quick just to recheck. So we come in here and we see that there would be a carryover. So at this point, I should not only use the 10, but also use the carryover as its own once it comes into that. So something like another bool maybe. Has carry is equal to carryover question mark 1. No, not this, question mark, of course. Colon 0. No, that's actually wrong. Is equal to 1, like that. So if we have a carry, then we're gonna have this carry over here, which is okay. I don't know if I can put a carry like an OR operator in here, or a carry, or has carry. So carry over is getting calculated by that if there is a 10 or a carry. Let's see if that makes sense now. I have no idea, but it sounds valid, kind of. Because we want to know that the first number or every number in this carryover also goes into the calculation. So currently we're going to see 1949, which looks valid so far. Let's see what's happening after dipping down. That is actually wrong, but it was, for a second, it was working. So in the next iteration, it still had a carry. It was working right. It was taking down the 8, but the carry has to be the has carry or the is10. One of them did not fire correctly at the last place. So the has carry I guess we're gonna put it out here. We start with false. We take away this. And we try again. Because, well, probably it will be always having a carryover. I really don't know. Okay, it has 0 carryovers. Now we should see 1 carryover. But what we can see is it's taking the carryover now into all of them except the last one. So in the next iteration, the carryover should be off again. Which actually should be this one over here. But the question now is, was the carry taken, or where was the carry actually taken from? Whew, why is that so hard to get? Maybe we don't put it in here, but at the very end, like after we do the calculation. Maybe that makes a difference, maybe. Because we shouldn't take this into the next iteration afterwards, but we still do. So this carry here is actually acting wrong. So it shouldn't go into each of them. So we need to make it so that the carry is not taken over too far. Pretty interesting. We don't really update his carry. So I believe this hash carry is pretty bad at this point. I don't know why. It should be something else. Maybe I'm gonna do something else, something like whatever the last digit has been. If the last digit has been an actual temp 10, of course then is 10 is true, otherwise it's false, but maybe I can do the calculation a bit different, or I need to put them in to this one here, like separately, that I'm gonna put the carryover like I implement a -1 over here, otherwise I don't do this. But that is another story, literally another problem I'm gonna have here, which means if that is a 0, or if that is a 0 and it says it's a 9, well, the carryover is not taken over to the next iteration. This is what the issue is going to be. So the carryover needs to be decided based on what the last number has been. So maybe I need to say carryover in here is equal to 1. And maybe we need to say, okay, if the last number has been, or the last number is a 9, from the last iteration is a 9. We don't want to overwrite this at the top. We need to do this at the bottom. So something like, okay, we're going to do a sum up here. So if the sum is a 9, we're going to set a bool to set has carry. Has carry is equal to, if sum is equal to 9, then we know that we have a carry. Because that should be the result for the next one. If the sum is, no, actually, if temp is 10. If temp is equal to 10, or, well, basically it's doing the same thing. What is the problem? The carryover needs to happen after, like the carryover calculation has to happen after the sum up, maybe. So let's get rid of that. So before we need to sum that stuff, like here we're gonna add them together, and we will calculate the sum. If we got a 10 first, we're gonna say, oops, we're gonna say that this one is a carryover after we are summing that things together. So the first one could not be a carryover, but it should have one actually, because, well, that's why. And if that is the case, then we are using 10, but we're going to set the carryover afterwards. Let's see if that makes a bit more sense now. Probably I was overcomplicating that a bit here. So let's see. Okay, so at least it starts correct now. Where's the carry calculation afterwards? And let's hope that this is becoming an 8 in the next iteration. There we go. That works. Finally. So it wasn't too heavy. I was just overcomplicating that on my own by doing the carry calculation before the summing up. So we need to make sure, or you need to make sure, that the summing up is going to happen before the carryover. So in that case, we can take the carryover within to the next iteration. We're gonna take it away from here, and so in the next iteration we're gonna calculate, was it a 10? Yes, no. If that is so, like based on this boolean, we're gonna set carryover to a 1, otherwise it's going to be a 0. Let's speed things up and see if that turns out quite good enough. Or let's assume we're gonna put not a 2000 here, but a 999, or let's say a 1000 and let's say 5. So we're gonna see if the result in the end is not going to be anything weird over here at the very top, or at the first place, because if the last number is going to be a 0, we want to get rid of that literally. So in that case, we want to get rid or clean up the element with the last element. If the last element is a 0, we want to clean up this number. Yeah, so now we got another issue with this number, it seems. But I wonder why that is the case. So let's take a 1000. So with a 1000, yeah, that's what I mean. Now we got a 0 here. So if the last element in the list is a 0, we want to remove the last index of that element. That's what we want to clean up first. Has carry is not needed anymore. At the very end over here, if sum of both in square brackets, maybe I can use dot last find last or last index of is in item. Last index of is equal to 0. Does that work? Nope. Dot length. That's no dot count. No, that's wrong as well. So if sum of sum of both dot count minus 1 is equal to 0. So if the last index, the last element in the list is equal to 0, then we want to remove the last index. So we're gonna say sum of both dot remove. And now we need to say what we want to remove. We want to say the last index literally, or any movement. We can also say remove at, and remove at is going to be at any index, and the any index is going to be literally sum of both dot count minus 1. Gonna copy that and put this in here. That should work to at least clean up the last one if the last number would be a 0 digit in our integer. So let's see if that works. At least for our 1000 we are starting off, so we should have a 99 left. There we go. And then we go forward over here. There was another issue. If I have another number like a let's say a 100 or 1005, if I take numbers away from that, it doesn't seem to carry over correctly. So we need to figure out why is that so. So it pops us into a 9 over here and gives us a 10 over there. Why is that so? That shouldn't give us a 10. Now we are at a 99 because the 10 was breaking down and the other one was being a 10, then reducing it or getting rid of element 2 in the list, and now when it is a 0 then it cleans that off. Fun fact, I don't know why it's taking the first index and not the last index. Because we are that's why we are gonna do the cleanup. We have to do the cleanup after, but then some of those cannot be cleaned up in this. Oh yeah, that should be right. If the sum of both after the for loop iteration over here is needing the cleanup, then it can do this, like if there's one number over there. Let's see. At least to get rid of the pop over. If I take away a number here, I shouldn't have a carryover in the very first iteration, but it looks different now. So we have 0 carry, 0 carry, 1 carry, 1 carry. How can these two have a carry? Ah, should be right. This one should have a carry. Or actually this one, oh no, it comes into it without a carry and then takes away the carry at this point, and then it should return a 9 instead of a 10. Why is that a 10 instead of a 9? So I'm not quite sure if that works correct. Let me pretty quickly test again. So we are starting with 1000, and the next iteration, when it becomes a 99, or should be a 999 without any issue. We should have 3 carry over, so a 0, 1, 1, 1 carry over, which is okay. We're gonna return a 999 at this point, which looks correct so far. Once the last number is going to be a carryover, it should become an 8, so a 989. So that works so far. Now again, I try to fiddle around why at 1005 is going to give us such a strange result, because it should know that it has to have a carryover to the next number, and it should be seen as a 10, yes. But why is it creating a 10 as a result if it has to take away one number, like the carryover in this case? Where is the issue with the carryover? Carryover should be in the second iteration. I don't get it. So maybe I need to put a carryover to be 1 here, if that is a 10, but it takes it from here anyways. So it takes it, but it does it wrong. It carries it to the last number, which is wrong. And the carryover should only happen after the complete iteration. Because the zero here is taking from the last one and takes it over to all of the numbers. But if there is like a 10,099, it takes it not onto the 99s, but on the other zeros over here. So that means we need to make sure that the number before had a, the number before was not a 0. Or was a 0 based on that. So not the current number, or not only the current number is important. Or probably it is like I minus 1 or I plus 1. If I plus 1, how do we go through the list? If I plus 1 is equal to 0, no, that doesn't make sense. Gonna need to do another nice painting. So let's pretty quickly check again. If I have a 1, 0, 0, 5, this is my starting number. I take away 1. If I take away 1 here, and there is a result, there's something left. If the result here, what is the result here? If 5 minus 1, if the sum no, we need to know if there's a rest. literally there is a rest. So for example, if we have a 5 here, or let's assume we have a 0 here, it has nothing to do with the 0. Because if I take a 6 away from here, I know that I have a rest. So if that minus that leaves a rest, then we have a carryover. And in this case, it's a carryover of 1. So it's not about the number 0 in this case, it's about the result. So that's what we need to do first. We need to do the sum here first. Copy. Oh, we don't know temp yet. And let's assume we're gonna, first off, I don't know if that is actually necessary, but if that result, like if sum is bigger, actually it is not really a sum, it's more like, you know, the result. If result is bigger, if temp minus, if 6 minus 7 would be a negative number, so if sum is not equal to 0, or is smaller, actually if sum is smaller than 0, this is actually what we need to know. If sum is smaller than 0, then carryover, copy, is equal to 1, else carryover is 0. So yeah, we can put this into expression, but that doesn't make more sense now. So if I put 0 minus 1, that's why I probably sometimes have these weird numbers. So if we got a 0 and we negate it by any number, so we're gonna say sum minus, we take the temporary number, literally we don't even need to. If I guess if 1i, it gives us any result. Let's assume we got a 5 here, or let's say we have a 0 here. That is the actual issue. If we have 1,000 here and we take away 1, we get this negative 1 over here. This is the actual issue. And so the carryover should now trigger because sum is smaller than 0. So if sum is smaller than 0, we don't want to add this here. If the sum is smaller than 0, then we want to set the result over there, and after we are done with that, I guess we get rid of that for the moment, then the sum of both should be added afterwards. We need to make sure that sum is actually equal to 0, so sum is equal to 0. Or what is sum? What is sum at this point? If it is 0? Let's assume we have a 6 and a 7, and 6 minus 7 would be minus 1. If we have an 8 and a 5, the carryover is not 1. The carryover is the rest. That is the problem. So if I have an 8 and no, let me do. We have a 1 here and we have an 8 here, like an 11. If I take 8 away from 1, I have a leftover of 7. That's the issue. So the carryover is the rest. The rest, absolute rest, is going to be the carryover. Carryover is mass f dot absolute of the sum. Isn't it? And the sum should be 0. Otherwise, the sum is going to stay the sum, and the carryover should stay 0. And then we add the sum of both should be 0. How about this? Didn't thought that would be so complicated here. Interesting. Carry is 1. So I have 1,000 here, and I get rid of 1. I believe I need to do two things. So if sum is smaller 1, then I need to oh no. If the sum is smaller than 0, that's what I want to know first. Debug.log. Maybe I'm wrong. I want to see the sum here. I'm gonna get rid of that because the carryover does not matter, and it told me that the carryover would be 1 anyways. What is the sum? The first one. So the sum would be -1 because 0 minus 1 is -1. If that is the case, we need to tell that sum is equal to 10 minus, I guess we need to store that somewhere first. Let's make an int temp. Is equal to 10 minus sum. Then we need to update sum to be equal to temp. And in that case, carryover is really 1. Actually, probably we don't want to put carryover in here, but maybe we will. Let's see. And then we have carryover in the next iteration, maybe. The sum is -1. Then we're going to take... Why is that not a 9? What do I get wrong? I have a 12, I want to get rid of an 8. What we know is that 12 minus 8 should be a result of 4. Oh, that is wrong what we do here, I guess. We need to take away this number there. 12 minus 8, 2. 2 minus 8 is 6. Then we need to take 10 minus 6, so that's going to be the rest, to be the 4 in the result. 2 minus 8 is negative, literally is negative 6. Okay, again, 12 minus 8. 2 minus 8 is 6, but it has to be as a minus. Then we need to go to the, we take this is, we have to keep it. Anyhow, because, well, we need to take this number in consideration as well. So we cannot go like that. We need to do this kind of the opposite way. So my calculation here is completely wrong, it seems. So if it is just a 0 over here, of course we can pick over there, but it would give us the wrong result with bigger numbers. So if we have 12 and we get rid of an 8, we should get a 4 in result. So this is what we want to achieve. How do we actually take this? How do we tackle this? We know it's a minus 6. That would be something to keep in mind. Minus 6. We need to store this negative number. What we then need to do is we need to keep, since we don't have anything left, we know that we have a 0 here, so we need to go into this one, take the 0 with us, and take the next number, which is this one, and put this here and see if the result, whatever would be the result, and if these two, sooner or later probably, are going to be, oh my goodness, that's complicated actually. How do we actually do this with huge numbers? Like let's assume we're gonna put in 199 over here. We have like always a rest. So if we take away not just 1, which is okay-ish, but if we take like this, like a 10, this is treated as a 10, but we don't know the rest of the number. The length of the number should be or might be needed. For example, we have a 112 and we have a, let's say, a 15 here. We would have the result of that would be a negative 3 because, well, this is a negative result. What we need to know is how high or how big is the rest of this. Then we need to take away 1 from the next. We need to say we take 1 out of the next number depending on how big this one number is. Is there a bigger one possible? Because then we need one here. From this, we take it from there away. From this point, so I plus 2, I plus 1, or current I plus 1. And then we gonna say, okay, we put this onto the 0 we have left over there. How big is that catch going to be? Let's assume we have a 19 here, and we want to take away a a 9 wouldn't, the result would be a 0. Then we are good to go. We can go to the next number and see if there's anything to do with that, which wouldn't be, because the sum is 0. So if there is a rest like this, after summing up these, we need to take the next, from the next number, how high it is, we need to take away a 1 and put this into here. So for example, if that is a 0 and that is a 9, and let's assume we have 110, when I take away from that, we can see, okay, 0 minus 9 would be a negative 9. So this is the highest catch. So we would need to take from this, from I plus 1, if it exists actually, because probably the number is not huge enough or this doesn't fit. We need to take a 1 and bring this into our, or to this number, whichever it is, and then take this as a number and do the calculation. And then whenever we are done with that, we go to the next number. This is probably the way we need to do this over here, because, well, we need to hop over it always into I plus 1 to get the correct result in the end. So in that case, if we do this, let's get rid of carryover, because I think the carryover is not, it's more like a true or false, which we can catch from here. If the sum is smaller than 0, then we need to say we actually need to change. We already need to change n1i plus 1. But then we need to figure if that is a 0 as well, and this, oh my god, this is going to be probably endless to be calculated correct, depending on if that is if n1i plus 2 is a 0 as well, or whatever the number is. So, but we need to figure out that result at the very first place. So before we add the result of the sum, we may need to manipulate the number beforehand, like again I plus 1 in this case, because we are going backwards literally in our iteration. Okay, so again we're gonna say the sum of n1 and n2 is a result. If the sum is smaller than 0, we need to do some magic anyhow. So that means we need to know what the result is. So we probably store the result pretty quick. So int temp or int result is equal to sum. I just put it in here together just to see what the result could be. So if we got a 12 here, like this, and we put away or take away an 8 here or a 4, something which is bigger than this. So then we know that the sum would be here would be a -2, so the -2 would be the rest. In that case, we need to have a temp number. Then we can make use of the temp number would now be equal to 10. That's what we need to take away from the next number, literally. And temp is 10 minus, well, actually temp plus sum, because, well, the sum is a negative number already. So plus and minus is minus, so minus and minus would be a plus. So that's what we need to say, 10 plus sum. And then we know at this point that carryover would be 1. So this minus here is just wrong, it's the opposite. Then we have a carryover, and in here we need to do, we have to do the carryover. We need to, in the next iteration, if there is a carryover, we need to get rid of that, because we were taking a number from the next one. We don't really change that, but we do this before we do the actual calculation. And so we take the carryover, and then we can set the sum to be whatever the result is of the temp, and then we add the sum at the very end. Is it that? I have no idea. So And then we're gonna do this cleanup, like if there's a 0 at the very first place, left literally, then like after the carryover, then we should be good to go. So the first number should be a 12, and the result after that should be an 8. Ta-da! Then we should have a 4, then a 0, and the 0 gets, you know, cleaned out, and then we got no numbers left. Awesome! That's awesome. Actually, we didn't use result over here, so we can literally get rid of that because we know the result based on the sum. We could also use that as our indicator. So that's how we can do this. Let's do this again with a 1005, a bigger number, so we see something happening over there, and hope that this is working right now. So the first number after a 1005 should be a 1001, which we got. Now the next number should be a 997. There we go. Awesomeness. It works like a charm. Pretty good. I know that was a pretty long session right now, but now we finally got it so far that the sum up and the subtraction from each other has worked perfectly. So there are probably some flaws about it, like if we go into the negatives. For example, we got let's say 100 here, and we got 15 here. No, 15 is bad. Let's take 17. 17 is better. And we probably end up with a negative number in the end. That's what I want to see at the very last place. I could also have started in the other way around. But let's see what's going to happen. So negative 17, pretty good, works like a charm. And now we should have, and this is the fun fact, we should have a negative 2 number. So what we do is we literally take the rest of, the 2 and take the 100, which has been initially there, which would be a negative number. So in the end, the result shouldn't, is taking care of that. There is no number possible actually. So if we take some bigger number from another number, which is actually not fitting, that's what you can implement on your own, by the way. It's just like if you can see if the incoming number literally is bigger, like in digits, if you go through all of them again and see, okay, is there a possible result of them? Like if you take them away, like if you have a 7 there and 2 1s over there, then you maybe find a way or figure out a way how you can actually make sure that you don't have an underflow under 0. So literally, like the 0 would be here, carryover would be there, but then if them two, something like if them two would be a negative number or something like that, that you just break out of it, or just say something like it's impossible, we cannot use that, or the result probably is going to be a negative result, something like that. Again, they would be, this is the fun fact over here, so the result, if it is a negative number, would be under that, and that's why it is taking the 10, add the negative number of the sum, and that's why it is starting at the very top again. So probably you're gonna put another catcher in here as well, so if the last, or if all the numbers, like an extra check, all the numbers or the sum of the result over here would be all numbers that would be literally negative at this point, then you're gonna break out of that, so if nothing helps. But you need to do this before you do this actual carryover calculation over here. Otherwise, it will, take this. This is what happened, right? It took over the one over there and to the other one as well. Negate them, take the same thing, and that's why it ended up in a 98. So again, you need to figure out if the sum of all numbers is not a negative number in the very end. If that is the case, again, then you probably wanna skip that piece and just break out and say, hey, negative is not possible. I could try that, but I'm already streaming like over 2 hours right now, which is more than enough for me. So the The actual result over here is literally the same thing as we did with the addition, so adding two numbers together, but in here we just need to take care that the carryover is correctly measured at our point. So again, for the negative numbers, you need to put in something on your own. If you like that stream, don't forget to subscribe to the channel if you haven't already. Don't forget to check the description down below where you can check out some of my online courses about how to create different games and different scenarios. You're going to find them once again down below in the description. Also check out my website OctoManGames.com if you need help for your project in the future or whatever, or at your current state. Just use the contact formula and write me a message, and probably I can help you out. Of course, you're gonna have to pay some fee for that, but you're gonna find all the information about that on my website OctoManGames.com. Check that out. Once again, if you like that, feel free to sum this one up if you haven't already, as well as leave a comment or any questions you have over there. Thanks a lot for tuning in. I hope you enjoyed this live stream, and I talk to you next time. Have a good one, and bye bye.